Hi everybody, welcome to another season of the Lunch and Learn Specials, and my name is Dana. I'm with the Technical Service Department at Nortech Global HVAC. With me today is also another member of the Technical Service Department, Greg Bruntz, and we're going to be talking about, for this Lunch and Learn session, the topic of troubleshooting a reversing valve for a heat pump. What we're going to focus on today primarily are two methods that you can use in the field to help you to determine if possibly you have a reversing valve that's at the heart of an issue for a heat pump that's not functioning well, either in heating mode or in cooling mode, or if there is evidence that might lead you to believe that possibly it could be something that's actually rooted in the compressor operation itself. What I'm going to start on first is what's considered to be an industry standard, if you will, that's held onto for a long time. It's a method whose information has changed over time. It almost has become something of a myth because this process of troubleshooting a reversing valve, the temperature has changed over time, and that's what can lead to a part of the inaccuracy or the confusion of using this method. But to begin, in terms of being able to effectively troubleshoot a reversing valve, I think it's important that you understand the basics of a reversing valve and what its job in a split heat pump system is. And so you're going to see that we've got a grand total of 4 refrigerant lines on the valve. We've got 1 line on the top side, and then we've got 3 additional refrigerant lines underneath. The line on the top side, that's going to be discharged from the compressor. Of the 3 lines underneath, we've got 1 line here in the middle. This line sitting in the middle is commonly referred to as true suction or common suction. This will always be cold vapor that's returning back to the compressor. Of the outer 2 lines here, those are actually going to be branching off. One will be returning to the indoor coil. One will be returning to the outdoor coil, if you will. Sitting right here, front and center, that is the solenoid for the reversing valve. And really what the solenoid is doing is just basically acting like a traffic cop almost, if you will. Because all that the reversing valve is doing is internal to the reversing valve, you have a slide. And depending upon whether the reversing valve solenoid and the pilot, I actually don't have the solenoid sitting on this sample here, so you have the solenoid and then the pilot here. What's happening there is that discharge from the compressor, depending upon whether the solenoid is energized or de-energized, the solenoid and the pilot are directing the discharge to either go to the indoor coil or back to the outdoor coil. And in the process of doing so, that then redirects suction gas and will either be redirected from one outer line back to the interior middle line or from this side back to the interior line. So the solenoid and the pilot are just acting as a traffic cop helping to direct discharge. When a reversing valve, and again, it depends on the manufacturer. Nortech Global, as an example, we energize the solenoid and the pilot. We energize this with 24 volts AC in the cooling mode. If you also notice here, you're going to see some capillary tubes that come off of here. When the solenoid is energized and the pilot opens or closes, what that will do, using these capillary lines, that's going to create a pressure difference on this middle vessel, this middle portion of the valve, and that will move that slide internally to one side or the other. So as an example, if we had discharge from the compressor here on the top side line and the slide were moved to let's say one side of the valve body, then discharge from the compressor will travel through this line. It will bypass the interior line and the outer line and then travel and either head to the indoor coil, so it's acting as the condenser. or it will send it to the outdoor coil in cooling mode where it's acting as the condenser. So all this is doing is acting basically as a traffic cop to send that discharge to one of the outer two lines. And in the process of doing so, then the suction gas, the cool suction gas, is going to be redirected back into that interior line. When you have a reversing valve that's beginning to malfunction and the slide begins to hang up, or sometimes it'll be referred to as bleeding by, what begins to happen is that the discharge on the top side here now is no longer completely being directed into one of these outer two lines in the same volume, if you will, each and every time that the slide attempts to move. So what begins to happen is you will have cool suction vapor that begins to mix with that discharge side. The result of that will be that your pressures will begin to equalize. If you were looking at your gauge set, your pressures will begin to equalize. They'll get closer and closer. Your discharge or your liquid pressure will begin to drop, and your suction pressure will begin to come up. It will almost appear as though you might possibly have a compressor that's no longer efficiently pumping. The one key thing, though, that you want to keep in mind is that even though you may see elevated suction and you may see a reduced discharge, in the event that you have a reversing valve that's actually hanging up, you still should typically see that you've got some rather appreciable amp draw on the compressor. A compressor that's really truly not performing any mechanical work hardly at all will have virtually no amp draw to it whatsoever, and they'll have a very, very, very low amperage draw on them. So the classical way of, or kind of what has always been an industry standard for testing to see if you've got a reversing valve that's hanging up, is either to test the temperature while the system's operating, to test the temperature of the discharge line on top, and then you might compare that to the temperature of what should be discharge going to the indoor coil or the outdoor coil, depending upon the mode of operation that you're in at that point. So let's say that we had this operating in cooling mode. So we were going to send our discharge from the compressor and dump that over into the outdoor coil to act as the condenser. If we were testing the temperature of this line on the discharge side, and we were to compare it to the outer line that would be dumping to the outdoor coil as the condenser, these two lines then should not be separated by anything greater than 3 degrees. That number right there, that is the number that's always been the source of controversy, because lots of guys have been taught 7 degrees, and then over time it became 5 degrees. And now most of the manufacturers, most of the service techs that do a lot of heat pump work agree that 3 degrees is really now the standard between what is an acceptable maximum differential from the discharge to what becomes discharge. Guys will also use that in terms of the temperature of what should be their cool suction. So again, if we were in cooling mode, we were testing the temperature of the top side to what becomes discharge going outdoors or the outdoor coil as the condenser, not being separated by anything greater than 3 degrees. Conversely, then the temperature of the true suction line and what would be the return cool vapor back to the compressor, those two lines then also should not be separated by anything greater than 3 degrees. That's classically been taught, trained, put out to the field. If you suspect you have a reversing valve that's hanging up, you should likely see elevated suction, reduced discharge, poor performance, obviously. And then if you were testing across these lines, that you should not have anything greater than 3 degrees from discharge to discharge, or from return vapor suction to suction, if you will. Depending upon where the slide actually ends up hanging up or stopping internal to this valve body, you won't always necessarily be able to say that you know for a fact that you don't have a stuck reversing valve, just simply because you might test from discharge to discharge and say, well, my differential is only 2 degrees. So that must mean that it's not my reversing valve. It's got to be something else. I'm going to be eyeballing that compressor as my actual source or my problem, if you will. And also the temperature. Again, one guy may be taught 3 degrees, another guy may have been holding on to 7 degrees for a long time. And so depending upon the severity or the actual location of where that slide body ends up hanging up and what you personally hang on to as far as the temperature split, can leave some question. It can leave some doubt in some of the guys' minds out there in the field if they, if they're not 100% sure that they actually have a valve that's still sticking. Having said that, presenting that information to you in terms of testing it by temperature split, I'm actually going to turn it over now to Greg, and he's going to show you an alternate method that you can also use in combination with testing by temperature that can help show you or even just physically illustrate to you out in the field of how you can see where the action of that slide moving internal to the valve body, how that would actually work. And he's actually got a pretty neat trick for how you would actually do that. So I'm going to go ahead and turn it over to Greg, and he's going to present to you the alternate way that you could troubleshoot a reversing valve.
All right, thanks, Dana. All right, guys, listen, I'm going to kind of cheat a little bit here. I'm going to use a cutaway view of the reversing valve so we can get a better understanding of what's really going on inside that valve. Looking at the reversing valve here, like Dana said, the discharge line on the top of that reversing valve is always going to be discharged. I just want to make sure everybody's clear with that. It never changes mode regardless whether you're in heating mode, cooling mode. The same with the center pipe on the bottom. That is always going to be suction. Heating mode, cooling mode, doesn't matter. The only thing that's going to change is whether this line or this line becomes discharge or suction. And if you look at the cutaway view of the valve, this little brass piece in here, it's cut open, but it's going to be closed. So if we're in one mode or the other, and then this way this valve is situated right now, suction is going to come up this pipe. It has to stay internal to this brass and out the suction on that side. The discharge comes in here, and it goes through and discharges into here. So you can see they're completely separated. This valve in this particular instance is shifted all the way one way. So obviously, but what we need to be able to do out in the field is obviously not going to take a hacksaw or a sawzall out to the job site and cut the valve open to see where it's at. So the temperature measurement is one way of doing it. Another way of doing it is by introducing some small little magnets. The only key factor is it's got to be strong enough to get through the brass to the slide to be able to pick it up. So what I want to do here is illustrate what's going to happen when the valve switches. So with the magnets on there, now this is going to be operated by pressure and electricity, or disengaging the valve. But just so you can see what's going to happen here, I'm going to manually slide this. And what I want you to really focus on is the magnets on the top. They actually slide with the valve. So if you were on a job and you were worried about it being stuck in the middle, and you're trying to determine whether it's stuck in the middle and do I have a valve that's just bypassing, with the magnets you can really quickly find out the position of that valve. Because if that valve is stuck in the middle, such as this, look at where my magnets are now. Look at the slide. The slide is not all the way shoved one way or the other. So if it was actually shoved all the way one way or the other, this one magnet on the outer side is all the way on that outer side. And as you can see, this magnet here is about the middle in between the discharge line and the outside of that valve. So one more time I want to show you what happens if it's stuck in the middle. As you can see, and I don't know if I got it perfect or not, but we're not all the way on the outside. We're not all the way on the outside here. Our magnet's like in the middle, or just about an inch away. That's kind of a good rule of thumb, maybe an inch or so. So you can very quickly see where the position of that slide is just by using a couple fairly high-powered magnets that will actually pick it up through that brass. So I hope that helps you in determining. I'm not going to take away from doing the temperature method, but I'm a visual kind of guy. So in my experience. If I can get something that's going to visually show it, that's what I'm going to do out in the field. So I hope that helps you. Even if you don't have a stuck valve, I encourage you to just get a couple magnets and try it. I will pass on that Granger, I know, is a good carrier of all different types of magnets like this. So if you're not sure what to get, maybe you can get your hands on an old reversing valve. You can get your hands on a new reversing valve. Take it over to Granger for you and try a couple different magnets on it and see which ones stick the best. All right, so one other thing we're going to try here, we're going to actually take these magnets and put them inside of a condensing unit that's operating and see if we can get you a video capture of watching the magnet slide on a reversing valve while it's running. And then we'll shift it from one mode to the other. And then while you're watching that video, if you got any questions you can think of or whatever, go ahead and start submitting those while you're watching the video. Okay, thanks for tuning in. Hope them tips helped you guys out in the field a little bit. A couple different ways of being able to troubleshoot reversing valves. So let's go ahead and get to some of the questions that came in. First question right off the bat here is it easier to troubleshoot the reversing valve in heating mode or cooling mode? Really, it's your option. You can do it either way. I always like troubleshooting in cooling mode myself because then I can use a jumper wire to jump to the O terminal or unjump the O terminal. I'm sorry, let me say that again. In heating mode, then I can use the jumper wire to jump from R to O, energize the reversing valve when I want, disengage it when I want. That way I got complete control. That was one good question. Let's see what else we got here. Let's see. If a stuck reversing valve is freed up, will it stick again? Yeah, if you get one freed up, and it might get you by for a little while, but it's probably going to stick again. Keep submitting your questions. Got some good questions coming in. Another one here is, could a failed reversing valve cause defrost issues? Absolutely. Especially if it's stuck. So if we're in heating mode and it goes into defrost and that reversing valve is supposed to shift to go into basically into cooling mode for defrost, if it ain't shifting, it won't defrost. That was a great question too. Let's see, another question here. What makes them stick? Wear and tear on the valve. Could be something wrong with if you look inside that reversing valve, there's like a piece of plastic there that has to slide back and forth. So any contaminants in the system can affect it. So I would definitely encourage, especially with 410A, purging with nitrogen while we're soldering and making sure we're keeping debris out of the system. Because any impurities in there get caught underneath that slide is going to keep that reversing valve from wanting to slide. So that could definitely stick it. Not enough pressure differential is another one. Especially if you get a reversing valve kind of sticking on you. If the unit's not performing properly and you don't have enough pressure differential across the reversing valve, just like we said before, the reversing valve is electrically initiated and pressure activated. So if we don't have enough pressure differential across that valve, it's not going to want to slide. So, great question. Another question here. Another question that came up was, is there a way to free up a stuck reversing valve? Yeah, but it's going to be temporary, but a couple different ways you can do it, and I've done it myself. So like if you got one stuck in heating mode and you're coming in, at the beginning of the cooling season, your customer has no air conditioning, and you really need to see if you can't free that valve and get it into cooling mode. What you can do is go ahead and start up the unit in the heating mode, and while it's running, let that pressure differential build, because it's going to build quickly if you got warm ambience outside. Let that pressure build up, and once it gets to a certain point, then just jump from R to O, and that's going to slap that valve with that huge pressure differential, and sometimes you can get that thing to slide over. And then what I would recommend is you leave the jumper on R to O so that it can't possibly get switched back. So even if the customer goes in there and turns the thermostat from cool to off or anything like that, that is going to stay in cooling mode so that they have air conditioning until you come back with the replacement reversing valve. Another way to do it is you can energize the valve, and then looking at the valve, you got to know where you need that slide to go, but if you get yourself a high-powered magnet, you can get it on the side of the reversing valve, and sometimes you can help it along and slide it into place, and that might get you by also. So that was a great question. Keep your questions coming in. These are great questions. Another question came in here is, what will the gauges read if the reversing valve is leaking by? Depends on the severity of it. As I was kind of showing in that, showing you that slide mechanism and that reversing valve, if it's dead center, you're going to have pretty well equal pressures. If it's a little bit off center, then you're going to have, a little bit of differential, but not a lot of differential. So it all depends on the placement of that valve. If it's stuck all the way in one mode, well, obviously we're just going to have either heating or cooling. So another great question. Keep submitting the questions. Kind of running out of questions here, so we're going to give it a minute here, give you guys some time, and hopefully we get some more questions come in. The next Lunch and Learn is going to be on the 20th of October, and we're going to do gas furnace tips, 10 gas furnace tips. So please make sure you tune into that too. I think that's going to be a good one for you guys. They're just little quick tips. And I've been hearing that some of you guys on iPads are not being able to get in, so I want to make sure you guys understand that if you didn't get in to see this, you can a couple hours after broadcast is over, we're gonna put it back on Nordine Interactive, and you'll be able to watch it again. So another question come in here. So let's see here. Another question came in. I like this question. Do Nortec reversing valves operate differently than the other brands? No, not really. Pretty much they're all electrically initiated and pressure activated. Some other manufacturers actually energize their reversing valves in the heating mode. We energize all our reversing valves in the cooling mode. So that's about the only difference I know of. There's a lot of different brands of reversing valves, but the theory behind how a reversing valve functions remains the same. That was a great question, though. Let's see what else we got here. Another question came in here is, so will it stick because of some contaminants? So purging this system to clean it all out. If you're changing a reversing valve, if a reversing valve is stuck mid-seat, stuck in one mode, we definitely got to replace the reversing valve to start with. but absolutely would not hurt to flush the system out, when we do that replacement, in case there is any contaminants in the system that cause that reversing valve to stick. So another great question. Keep your questions coming in. Questions we've had so far have been great. Give you guys a few more minutes and maybe get some more questions coming in. I know reversing valves, a lot of times, that's the hardest thing in the system to diagnose, because in a heat pump system, you've got basically your compressor, your metering device, and your reversing valve are the key factors that separate the system, separated from high pressure to low pressure. So if we got one that's got equal pressures, there's only 3 components that can cause that. It's either going to be the reversing valve, or the compressor's not pumping, or you got a failed metering device. The failed metering device, you'd almost have to have one that's not metering at all. It's just letting your pressures be completely equal. Those are usually fairly easy to troubleshoot. When it comes down to troubleshooting between the compressor and the reversing valve, that's where it gets a little tricky. So I'm hoping these tips we've gave you guys will help you in determining for sure what's wrong. Is it the reversing valve or is it the compressor? We take these calls a lot, and working with guys and trying to get them to, test that reversing valve. It's not a fun job to do. Changing reversing valves is not a fun job to do. I've changed reversing valves myself. I would rather change 5 compressors over 1 reversing valve, because it is. I feel you guys' pain. I've been out there. So we really want to make sure we're making the right decision. Is the reversing valve or is the compressor bad, so we can make the appropriate repair? Because I know you guys don't want to change reversing valves if you don't have to. So we got some more questions coming in here. So we've got one question in here, came in. Do you recommend any oil additives being before replacing reversing valves? I don't recommend any oil additives. The only one we've been recommending and that was due to the POE oil issue with the Copeland compressors, and that was the AC Renew. But as far as additives into the system, Copeland being our primary compressor manufacturer, they don't want additives in the system, so we really can't encourage putting additives into the system. Another good question here. Okay, another great question here, and it's kind of a long question. So the question is, if the valve is stuck in one position and the valve moves internally as it should, is it likely that the coil that activates the valve is an open circuit? Is that simply a matter of ohming it out? Yes, you can ohm out the coil, because you're either going to have an electrically open coil, or you could possibly have a shorted coil, or you could have a proper coil. The thing that's tough to know and remember, especially if you're servicing multiple brands, because I like to, I want you guys doing Nortec product, but I mean, most contractors, including myself when I was out in the field, serviced all makes and brands. So knowing that ohm value for everybody's coil is tough to remember all that. So I err on the side of caution. Is it open or not? And then what I really want to do is test it for voltage. If I'm getting the voltage to the valve and the valve is not electrically energizing, and you can do simple as take a screwdriver to the side of that solenoid, you should feel the magnetism on the side of that solenoid. but we want to check that voltage to the reversing valve while it's plugged up. That's not easy to do. So you need to do it down the valve, pull the plug back a little bit, and get your voltmeter on there, because anytime you're checking voltage, you need to do it under a load. Because just because you've got voltage to the wires, once you plug it up to the load, do you have voltage then? So if we're getting voltage to it and the coil's not energizing, you're not feeling the magnetism, then yes, you got a bad coil. That was a great question. See what else we got here. Another great question here. If you're replacing a reversing valve, should you replace the filter dryer? Absolutely. Anytime you open any refrigeration system, and I say refrigeration system because an air conditioner is a refrigeration system, anytime you open a refrigeration system, you should be replacing the filter dryer. Great question. Got to running out of questions here, guys, so if you got more questions, go ahead and get them submitted in here. Be happy to answer them. These are great questions we've had so far. Okay, guys, thanks for tuning in. I hope these tips helped you guys. Again, October 20th, we're going to be doing the tips on the gas furnace tips. So really appreciate everybody tuning in, and have a great day.